Welcome back to the channel, everybody. Today we're talking microprocessors, those tiny chips that power, well, pretty much everything around us. From our phones and laptops to cars and even refrigerators, microprocessors are the brains behind the operation. We're going to take a trip through time, exploring the major generations of these silicon marvels. In just 10 minutes, we'll go from the first rudimentary chips to the multi-core monsters we have today. So buckle up, hit that subscribe button if you haven't already, and let's dive in. Our journey begins in the early 1970s, a time when computers were these massive, room-filling machines. These behemoths were not only large, but also incredibly expensive and limited to a few specialized applications. They were the domain of large corporations, government agencies, and universities. But things were about to change. In 1971, Intel released the 4004, the world's first commercially available microprocessor. This tiny chip was a game changer. This 4-bit CPU was incredibly basic by today's standards, capable of only a few thousand operations per second. Yet, it was a marvel of miniaturization and engineering. But it was a revolution, shrinking an entire CPU down to a single chip. This innovation opened up new possibilities for computing, making it more accessible and affordable. The 4004 found its way into calculators and early computers, paving the way for its successor, the Intel 8008. These early applications demonstrated the practical utility of microprocessors in everyday devices. Released in 1972, the 8008 was an 8-bit processor, offering a significant leap in processing power. It could handle more complex tasks and process data more efficiently. It was still limited, but it showed the potential of what these microprocessors could become. The 8008 laid the groundwork for future innovations, hinting at the vast possibilities that lay ahead. Imagine trying to edit a video on one of these early chips. It would probably take you longer than the lifespan of the sun. The processing power was minuscule compared to today's standards, but it was a start. But back then, this was cutting-edge technology, laying the foundation for everything that would follow. These early microprocessors were the seeds from which the modern computing world would grow, revolutionizing industries and changing the way we live and work. Fast forward to the mid-1970s, and we enter the era of 8-bit microprocessors. This was a transformative period in the history of computing, where the seeds of modern personal computing were sown. This is where things start to get really interesting. The Intel 8080, released in 1974, became the brain of the Altair 8800, widely considered to be the first truly personal computer. The Altair 8800 was a groundbreaking machine that captured the imagination of tech enthusiasts and hobbyists alike. This sparked the imagination of hobbyists and entrepreneurs, leading to the birth of companies like Apple and Microsoft. These visionaries saw the potential of personal computing and began to develop software and hardware that would revolutionize the industry. The Motorola 6800, also released in 1974, was another major player in the 8-bit arena. It was known for its elegant architecture and robust design, making it a favorite among engineers and developers. It was known for its elegant architecture and found its way into early gaming consoles and home computers. The 6800's versatility made it a popular choice for a variety of applications, from gaming to home computing. These 8-bit CPUs were still relatively limited in power, but they were becoming more affordable and accessible, leading to a surge in personal computing. The affordability of these processors meant that more people could experiment with and own personal computers, paving the way for the digital revolution. We're talking about computers you could actually have on your desk, not taking up an entire room. This shift marked the beginning of a new era, where computing power was no longer confined to large institutions, but was available to individuals in their own homes. As we move into the 1980s, the demand for more powerful computers continued to grow. This led to the development of 16-bit microprocessors, and two giants emerged: the Intel 8086 and the Motorola 68000. The 8086, released in 1978, laid the foundation for the x86 architecture, which, believe it or not, still powers most of our computers today. It was a game changer, offering significantly more memory addressing and processing power. The Motorola 68000, released in 1979, was another powerhouse. It was a more advanced design and was used in popular computers like the Apple Macintosh and the Commodore Amiga. These 16-bit processors brought about a revolution in personal computing, enabling more complex software, graphics, and gaming experiences. We're starting to see the ancestors of the computers we use today. The late 1980s and early 1990s saw a seismic shift in computing, a period marked by rapid advancements and groundbreaking innovations. One of the most significant developments was the arrival of 32-bit processors, which revolutionized the way computers operated. Intel's 80386, released in 1985, ushered in this new era. This processor was a game changer, setting new standards for performance and capability. The 386, as it was known, could address a whopping 4 gigabytes of memory, a massive leap from the limitations of its predecessors, which could only handle a fraction of that. This increase in memory capacity allowed for more complex and powerful applications, transforming the computing landscape. This paved the way for more powerful operating systems, software, and of course, games. Developers could now create more sophisticated programs that took full advantage of the new hardware capabilities. The 32-bit revolution wasn't just about Intel, though. Other companies and technologies also played crucial roles in this transformative period. We saw the rise of RISC, or reduced instruction set computing architectures, which offered a different approach to processing. Processors like the MIPS R3000 and the ARM architecture began gaining traction, providing alternatives to the dominant Intel designs. RISC processors focused on simpler instructions that could be executed more quickly, enhancing efficiency and performance. This offered an alternative to Intel's more complex CISC, or complex instruction set computing design, which had its own strengths and weaknesses. This era was all about pushing the boundaries of what was possible, with each new development opening up more possibilities for innovation. The pace of innovation was incredible, with breakthroughs happening at a dizzying speed, forever changing the world of computing. As we entered the mid-1990s and early 2000s, the demand for even more processing power continued to soar. This led to the transition to 64-bit processors, which could handle even larger datasets and more complex computations. Intel's Pentium architecture, first introduced in 1993, dominated the PC market, but it faced stiff competition from rivals like AMD. Meanwhile, the PowerPC architecture, a collaboration between Apple, IBM, and Motorola, emerged as a powerful contender in the workstation and server markets. And let's not forget about ARM, which, although not yet dominant in PCs, was quietly gaining momentum in the embedded systems world, powering everything from printers to mobile phones. This was a time of fierce competition, with each company vying for dominance in this rapidly evolving landscape. And that brings us to the present day, where we're living in the multi-core era. Instead of just making processors faster, manufacturers started adding more cores to a single chip. This allowed for parallel processing, where multiple tasks could be handled simultaneously. Intel's Core architecture, introduced in 2006, and AMD's Ryzen architecture, launched in 2017, exemplify this shift toward multi-core designs. But it's not just about CPU cores anymore. We're seeing the integration of graphics processing units, or GPUs, directly onto the CPU die, dedicated AI processing units, and a focus on power efficiency, especially in mobile devices. The lines between traditional CPUs, GPUs, and other specialized processors are blurring, leading to what's known as heterogeneous computing. So, there you have it, a whirlwind tour through the evolution of microprocessors. From those humble beginnings with the 4-bit Intel 4004 to the multi-core behemoths of today, it's been an incredible journey of innovation. And the future? Well, it's only going to get more exciting. Quantum computing, neuromorphic computing, and other mind-blowing technologies are on the horizon, promising to revolutionize computing once again. If you enjoyed this deep dive into the world of microprocessors, give the video a thumbs up and let me know in the comments what tech topic you'd like to explore next. Don't forget to subscribe and hit that notification bell so you don't miss out on any future tech breakdowns. Thanks for watching.